and then 10, 0. That's the intersection of this circle and this line right there. And I'll do another one for you. Y equals log of x plus 4 and y equals x squared. So you got a parabola and then you got your log. This one's going to look just not nice, pretty numbers, but it still will intersect for you. So let's do this one real quick. Now for log, I have to actually type it in. And go to function and hit miscellaneous and do log of x plus 4. And there's the green line that came up. And then this one, y equals x squared. And you can see they actually have 2 more points. Let me zoom in a little bit. It also has 2 points of intersection. And these are decimals, so you'd actually have to write them down. Negative 0.718, 5.16, and this is 0.827.684. There's your point of intersection. I mean, that was just amazingly quick. In the calculator, you have to actually hit a sequence of event like second calc 5, enter, 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 and then you have to move the cursor over. So I will say the superiority of Desmos for graphing is incredible. So again, those numbers were negative 0.718, comma 0.516, and then 0.827 and 0.684. And that's all you'll have to do. All right, so that is the first part. You would write. Yes, hello?
Can you screen share it? Because I can't see what you're writing.
I can. Is it not doing that? Thank you. There you go. Oh, and then it just switched over. Okay. Thanks, Rachel. So we're going to write out the augmented matrix. So we have, like I said, our X's, our Y column, and then our 3. So we want our system to be in correct order. It's called standard order. So now we're just going to write the coefficients, -8, then a 4, then a 3, a 2, a -3, and a 6. And you put it in these brackets. And that's it. That's the augmented matrix. That's all you have to write. It's very easy. Let's do another one. Let's do it for a X, Y, and Z. So here I have X minus Y plus 14Z equals 9. Y minus 4Z equals -5, and then Z equals 2, and they want you to write an augmented matrix. So again, this one will be a little bit longer. Your top row would just, again, be just all the coefficients in front. So a 1, a -1, a 14, and a 9. So 1, -1, 14, and 9. Now in the next row, you don't have an X, so you put 0 here. But you do have a Y, which is 1. And then you have a Z, which is -4. And then -5 is what it equals. On this last row, you don't have an X or a Y, so you put 0 and 0. But you do have a Z, which equals 2. And that right there is the augmented matrix. What you sometimes, some books do is they put like a little dash right here. And that dash just means that's what it equals, that last row, that last column is what it equals. So there you go. You just wrote out augmented matrix. Easy questions. Now let's work backwards. What if I give you a matrix and I want you to write out the system? Okay, so pretty easy. Your first column is usually your X's, and then your next column is Y. And then if you have whatever your last column is what you equal. So this right here would be what I equal. So I really only have an XY for this. So just think of it like this is my X, this is my X, this is my Y, this is my Y, and then write out the system. So the system would be 2X minus 3Y equals 6. And then this bottom, this would be 5X plus 5Y equals negative 3. Done. You don't have to solve it. You just have to write it out. Easy peasy. This one, and again, that last column is what you're equal to. So think of this as being the equals. So my first column would be the X, then a Y, then a Z. And it looks like I have an X, but I don't have a Y, and I don't have a Z. So all you write is X equals 2. This one, I don't have an X, but I have a Y, and I don't have a Z. So Y equals 9. And this last one, I don't have an X or a Y, but I do have a Z, and Z is 4. And that would be my system right there, completely solved. Okay, now how is this useful? Let's find out how this actually comes into play. This is really exciting stuff. It just, believe you me, I can teach you how to solve these all by hand. I do that, I actually make my pre-calc students solve them by hand. But the calculator is so much better. So what, excuse me, what you're going to do is when it says solve X, Y, and Z, you're going to write it as an augmented matrix. Okay, so that's the first step you want to do. So let's write it as an augmented matrix. So this again would be 1, 1, 1, 8. Then 2, 1, negative 1, 11. And then 1, negative 1, 1, 4. Okay, now you are going to go into your calculator and you're going to go into what's called second matrix. And you're going to edit a matrix. So let me show you right here. If you hit the second button and then right below the word math, it says like X to the negative 1, that's the matrix button. And you can see here, it has names, math, and edit. Now, I've already put, excuse me, in my A matrix and my B matrix, I've already put a 2 by 3 matrix inside of them. So I need to edit those. So I'm going to go over to edit. And it looks like it's the same thing. Well, you're just going to hit enter. And then you have this matrix and it's a 2 by 3, it says. Well, I don't want it to be a 2 by 3. I want it to be 3 rows, 1, 2, 3, 4 columns, 3 rows, 4 columns for this one. So I'm going to type 3 and 4. And notice what they did. Now I have enough spaces to type all of these numbers in. So I type 1, enter, whoops, lost my thing. 1, enter, 1, enter, 8. And then 2, enter, 1, enter, negative 1, don't type minus, type negative, 11. 1, negative 1, 1, 4. Okay, so this is my matrix A, and it's all the coefficients. Once you've typed it in, so I've edited A, then you're going to perform something on it called reduced row echelon form. You're going to go to second matrix, and then you're going to go over to math and type RREF. That is your best friend right there. So let me get out of this, quit. You're going to go to second, back into the matrix. See how I have that A, it's still in there? But I'm going to go over to math first. I'm doing this matrix, this math operation in the matrix. and scroll down until you see RREF. See how there's an REF? Go to RREF. It's called reduced row echelon form, and that's the one you want to choose. So RREF, and when you hit enter, it should come up. Then you go back into the matrix, second matrix, whoops, and hit A, where you typed in that matrix. And then just hit enter. And what comes up are all the answers. This right here is what you want to see. You want to see a diagonal of ones and zeros everywhere else. And then you want to see that last column hopefully be numbers. What you've just done is solved. So you want to see this 0, 1, 0, 0, 0, 1, 0, 0, 0, 1. This is your X, this is your Y, this is your Z. This last column, see what I had? I had a 5, a 2, and a 1, is really what those variables equal. My X is 5, my Y is 2, my Z is 1. And that's my answer. And you can do that with any system. It's amazing. It solves it for you. It does it like 1, 2, 3. So let's do another one though, just so you can get used to this. All right, so here again, I have 3x plus 3y minus 12z equals 10, 4x plus y minus z equals 5, negative x minus y plus 4z equals 2. So the first thing you want to do is write it as a matrix with all the coefficients. So 3, 3, negative 12, 10, 4, 1, negative 1, 5, negative 1, 4, and 2. Okay. Now again, let's go through the process. You have to edit matrix, and usually since A is already a 3 by 4 column, I'm going to go back into A. So hit second matrix and edit A. And then it's still a 3 by 4, but you just have to change these numbers now. So it's going to be a 3, 3, negative 12, 10, 4, 1, negative 1, 5, negative 1, negative 1, 4, and 2. You can't see there. So now I've renamed matrix A to have this augmented matrix. And then go back out, go back into the matrix, but this time go over to math. You're going to perform the RREF on it. So go over to math, go down until you see RREF. There it is. Go back into the matrix and hit A. And then hit enter again. And now let's see what we have here. Oh, something different happened. Okay, let me write it out. 1, 0, 1, 0, 0, 1, negative 5, 0, and 0, 0, 0, 1. Okay. Remember up here at this one where we had all the ones in a diagonal and zeros everywhere else? That was a beautiful answer. My X value was 5, my Y value was 2, my Z value was 1. It worked out beautifully. This did not. Doesn't have a 1 in this diagonal. It actually has a 1 up here and a negative 5. This is not working out. This right here is what's considered an inconsistent solution. I have 0 for X, 0 for Y, 0 for Z, but somehow it equals 1. So this is what we call an inconsistent, oh, I can't spell inconsistent, inconsistent, or no solution. There's no X, Y, and Z value here that will work. So boo. But I want to show you that because it will happen. If you do end up with something like that, then your answer would be no solution. All right, let's do another one. Now this one's interesting because it's got an X, Y, Z, but it's only a 2 rows by 4 columns. This is a 2 by 4. But we're still going to perform a row echelon on it, a reduced row echelon. So let's go. Well, first let's write it out. This would be 3, 5, -1, 7, 1, 1, 2, and 6. Okay. 2 rows, 4 columns. So again, I have to rename my matrix A by going into the matrix, second matrix, edit A. This time it's a 2 by 4. And I'm going to put in my numbers. 3, 5, -1, 7, 1, 1, 2, and 6. I'll go back out. At this point, by the way, if you already have done RREF A and you changed matrix A, you can actually just hit second enter and it repeats RREF A, but it will use the A that you put in. So I'm just going to do that. Okay, so let's see what we got here. So we got 1, 0, 5.5, 11.5, 0, 1, -3.5, -5.5. So we kind of have this diagonal, but we're missing an entire row to tell us what Z is. So, oh, and I do want to show you, you can change decimals that are terminating. You can hit math and then hit frac and then hit enter again. It'll actually make them into fractions. You might want to do that, I think, on the homework tonight, like change them back into fractions. So let me write this down. So I have 1, 0, 11 over 2, and 23 over 2. And then 0, 1, -7 over 2, and -11 over 2. Okay, so this is not an inconsistent solution. This is actually an infinite solution. You have, if I were to write this out like a system, I'm kind of running out of room, so let me move over here. This would be X, this would be Y, this would be Z, and this is what they equal. So I have X plus, remember this is my Z, 11 over 2Z equaling 23 over 2. And then this right here, I have Y, and then that's my Z. Oh, sorry, my dog got a little crazy. I have Y minus 7 over 2Z equals -11 over 2. And again, what you have is an infinite solutions here. And like I said, they will then require you to solve for a variable, meaning they'll actually say on MyMathLab, okay, well, in this case, since they both have a Z, I want you to solve for X and solve for Y. And it's really not that hard. So again, you just want to solve for X. You want to get this X by itself right now. Okay, so you're going to minus that 11 over 2Z to that side. And again, I'm sorry for running out of room, but you'd have X equals 23 over 2 minus 11 over 2Z. So you write it as an expression for X. You'd say, okay, and actually they want you to write it like this, 23 minus 11Z over 2. That would be your X value expression. That would be the X value that you can find given a Z. And then same thing for Y. Get Y by itself, so bring this Z term over. You'd have Y equals -11 over 2 plus 7 over 2Z. Or another way to write that would be negative 11 plus 7z over 2. And again, like I said, they'll tell you this, but you'll be able to figure it out because it'll be the only variable you'll have here would be an x and a y, or you might have an x and a z, so then you'd be solving for y. But that could also happen. That's an infinite solution. So notice the difference here. An inconsistent solution ends up with this third row, and that third row like has something like 0 equals 1. It's missing the diagonal. Whereas, you know, an infinite solution, you actually still have the diagonal, and you can actually rewrite the x and y values in terms of z, or you could write x and z values in terms of y, etc. All right, now let's do a word problem. I know, super exciting, but I got to show you these 2 word problems so that way you can see how it all kind of comes into play. My dog is playing with my son's fidget spinner. So, a person invested $8,200, part at 8%, part at 9%, and the remainder at 13%. The total annual income of these was, did I say of these was? Okay. Of these was $895. The amount of money invested at 13% was $400 more than the amounts invested at 8% and 9% combined. Find the amounts of each rate. All right, so again, I like to do tables, and for this question, I am investing into 3 different total. I'm putting my $8,200 into 3 different percentages. So I'm going to have A that I'm going to invest, B that I'm going to invest, and C that I'm going to invest out of this 8,200. Now remember, it's rate, or your percent, times the amount equals the total. So we'll call investment A is my 8%, so 0.08. We'll call B is my 9%, so 0.09. And then C will be the 13% remainder. And now, again, we don't know that much about the amount of money we invested, except for this clue right here. The amount of money invested at 13% was $400 more than the amounts invested at 8 and 9% combined. So that's important. I don't know how much was in the 8 and the 9%, but I know that the amount here is 400 more than those. So a way to do this would say, okay, I'll call this amount X and this amount Y, and then combine them together, I would have 400 more in this account. So X and Y plus another 400 would be what's in this 13% account. That's what that's saying. The amount of money invested here at 13% was 400 more than the amount in 8 and 9% combined. So that wasn't too hard, but you'll see something like that on homework tonight. Now just multiply across 0.08x, 0.09y, and then this one obviously 0.13 times x plus y plus 400. Now, just like in the previous section, where do I get my systems from? We'll go back up to the story. A person invested $8,200. That is their amount total that they have that they're investing. So this column right here is going to equal $8,200. So x plus y plus x plus y plus 400 makes 8,200. That's your first equation. Your second equation deals with the income that they got, the extra income that they made. Well, it says the total annual income of these was $895. So this total right here was $8.95. So 0.08x plus 0.09y plus 0.13 times x plus y plus 400 equals $8.95. Now, y'all, we cannot have this and type it into a matrix. We got to clean this up. So you do have to do a little bit of math. It's not that hard though. I mean, look, x plus another x, oh, 2x. Y plus another y, 2y. And then you see this 400 here? Just subtract it over. So 7,800. And you're going to do the same thing here. You know, you got to distribute that 0.13 to all of these. So 0.13x plus 0.13y plus whatever 400 times 0.13 is. 52. So I'm just going to add 0.08x and 0.13x, and that would be 0.21x. Notice how I'm writing it in an order. And then 0.09y and 0.13y is 0.22y. And then take that 52 and minus him from 895. 895 minus 52 is 843. Now this is what we're going to RREF. And as you can see, this is a 2 rows, 1, 2, 3 column. This is a 2 by 3. So let me put this into my calculator. Second matrix, and I am going to edit. I'm actually going to edit B because my B is already a 2 by 3. And I'll keep it 2 by 3. I'm going to change this to a 2, and this to a 2, and this to 7,800. And you can put decimals, 0.21, 0.22, and 843. And then go back to the home screen, go back into the matrix, over to math, RREF, back into the matrix, and then hit B. And look at that, if you can see it. You got your diagonal ones, zeros around, and then that last column is your answer. Your X is equal to 1,500, and your Y is equal to 2,400. Now, just make sure you remember which one is X. X was the 8%, and then Y was the 2,400 here, and then you just find X plus Y and add 400 to get the 13%. So you'd say 1,500 would be at 8%, 2,400 at 9%, and then X and Y, and then another 400, which was the 4,300, would be at the 13%. And that is really, really neat. I mean, like, that the calculator, that's why I didn't solve the other one we just did before, because I'm like, oh my gosh, we can solve it so easily with a matrix. All right, I'm going to do one more. I'm going to do one more while my dog chews my son's fidget spinner. And it's a word problem again, but there's like 2 different kinds of word problems on the homework tonight, so I just wanted to get it done. And this one is about sparkling water. Sparkling water distribution wants to make 500 gallons of sparkling water to sell for $8 a gallon. The distributor mixes 3 grades of water selling for $12, $2, and $4.50 per gallon respectively. She must use twice as much of the $4.50 water as the $2 water. How many gallons of each does she sell? Okay. So again, she's got 3 different kinds of waters that she's selling. $12 water, a $2 water, and a $4.50. So again, I just call it ABC. It's my group. And then, so this one is similar to the one we did with the investment, but it's a little bit different because we have the amount, we have the price per sparkling water grade that we're having. So we're going to have, instead of like a rate or a percentage column, we're going to have a price column. Check. And then you always have an amount. And then you always get a total. Okay. So we'll call sparkling water A the $12 price. This one we'll call the $2 price. And then this one is the $4.50. All right, now we need to, call one of them X and call one of them Y and try to figure it out. But there was this extra piece of information that they wrote, if you caught on, she must use twice as much of the 450 as the 2. Okay. Jack. I'm sorry, my dog is going crazy. Stop. You need to leave. Goodbye. Keep knocking my camera over. She must use twice as much of the 450 water as the $2 water. Okay. Meaning, if I call this X, she needs to use twice as much of it. Twice as much of the 450 as this guy. So this would be 2X. She must use twice as much as the 450 as the $2. So we'll call him X, and this would be 2X. Then the seltzer, the sparkling water A, we'll just give them the variable Y. All right, now multiply everything over. 12 times Y is 12Y. 2 times X is 2X. 450 times 2X is 9X. All right, now let's write our equation here. So we got to go back up to the story. Remember, your two equations usually come from the amount and then the total. So let's find out if there's an amount. Sparkling water distribution wants to make 500 gallons. Ah, there's an amount. I need there to be 500 gallons total here. So Y plus X plus 2X equals 500. There's my first equation. Now, where would the price come from? That's the question. So I don't know if you caught on to the first part, but it said sparkling water distribution wants to make 500 gallons of sparkling water to sell for $8 per gallon. So you're selling 500 gallons of water at $8 a gallon. 500 times $8 a gallon is $4,000. So the total price here is $4,000. And so that would be my second equation, 12Y plus 2X plus 9X equals 4,000. Now again, I don't like the way this is written. I want my X's to be first, my Y's to be second, and I can combine some like terms here. So this right here would be 3X plus Y equals 500. This one on the bottom would be 11X plus 12Y equals 4,000. And this is going to be what we put into our matrix. So let me do it one more time with you. Hopefully you've caught on by now, but I know for some of you this might be new. But it's really easy. You go in, everything you need is in the matrix. I love saying it like that. I feel like I'm talking about the movie, but go into the matrix. If you go into the matrix, this is a 2 by 3 column. 2 rows this way, 3 columns. So I will edit, and I'm going to edit matrix B because I already had it as a 2 by 3. So it's a 2 by 3, and I'm going to put my coefficients there. 3, 1, 500, 11, 12, 4,000. and then go out. But then you got to go back in because you have to perform the operation. The operation is RREF. So go over to map and go up or down to RREF. Whoops. Sorry. There we go. Then go back into the matrix and this time choose B from that front screen. And just hit enter. And then you have your diagonal 1, 0, 0, 1, 80, and 260. That means, and again, you got to remember what this is. This is my X value is 80. And this is my Y value of 260. And go back up here to your chart. X is the $2 price seltzer. So you were going to sell 80 gallons for $2. 260 gallons. That was the $12 price seltzer. And then to figure out the 2X, well, that would be 2 times 80 or 160 gallons would be at the $4.50 price. That's how much you would need to figure out how many gallons of each you would need to sell. All right. So with that said, that's it. I mean, it's really not too bad. Hold on, let me stop sharing. Does anybody have any questions? I mean, everything, honestly, you can do everything.